Welcome to NetworkNuts YouTube channel. My name is Alok and in this video we are going to talk about Kubernetes storage classes. So storage class is a wonderful thing. Let me give you an idea what will happen if we don't have the storage class. Now the prerequisite for this video before you move ahead is that you should be very good with Kubernetes. You should have knowledge of persistent storage. You should have concepts like PVC and storage classes clear. Not exactly the storage classes, but you should be familiar with the idea behind the persistent storage. So my application need to store data. What happens? Suppose this is my Kubernetes cluster. This is my Kubernetes cluster, K8 as cluster. So we have a cluster here, which will be containing a lot of machines, workers, managers, all that. We have manager, we have couple of workers, say worker 1, worker 2, like this. I should write the names here. Wait a minute. Okay, so we have multiple. This is my manager. This machine, I call it my worker 1. This I call it worker 2. Obviously they will be connected somehow, and somewhere in the data center I have a NFS storage. So this is my NFS server here, right? This is my NFS server, and suppose the IP address of this is 10.0.0.99, which is, in my case, I have this IP address on my NFS server. So and obviously they are connected with each other, so connectivity is not a problem. So I'm assuming they are properly connected, but this machine NFS server is not a part of the cluster. That we need to understand. It is on the network but not a part of the cluster. So this is the scenario. So if we don't have the storage class, what will happen? Now think of it. If we don't have a storage class, and suppose on this NFS server I have I have a big block device, right? I have a big storage connected to it. We have one block device is connected here, a big block device of 1 terabyte, right? So this is a 1 terabyte block device which is connected here. Now I have to share this block device as a shared storage to my applications which are running on the Kubernetes cluster. So if we don't have the storage class, what will happen then? So my cluster will be used by different teams, team A, B, C, or call them dev test prod. So we have different teams which are using the cluster. Let's suppose we have a dev team here, right? Dev team is also using my cluster. Then we have a test team, right? Dev, test, prod. So we have a test team also who is creating applications, and say another one, let's say prod is also there, dev, test, prod. They are using the cluster. So they will be creating a lot of applications. Dev will be creating a lot of applications. Prod will be creating a lot of applications. So if, as I told you, you should be familiar with the Kubernetes and the persistent volume subsystem concepts. So for every application, what I'm creating, I have to request the storage guys. Right now, the storage part is being managed by the storage guys. So this is not under your control, right? NFS server, this is being managed by the storage team. Storage team will be managing this, and whereas this part is your domain, right? This is your Kubernetes team. K8s team will manage it. So for every application which you want to have the storage available, you have to request the storage team, hey, create a folder, right, and share it in the NFS. So let's suppose dev is trying to create an application, say ABC, and they need a storage. So they have to request the storage team. Then the storage team will be doing say mkdir, try to understand this, right? Say ABC, right, create a folder and then modify the entry in etc exports, isn't it? Every time they have to create an application and that application is asking for the storage guys had to create a folder, update the etc export. Now tomorrow test is trying to create an application XYZ, then these guys have to again create a directory for it, mount it separately, right, XYZ, and then again update etc exports for it. So this is a tedious job for the storage guys, right? Prod is also creating an application, say LMN. So again they have to create a folder mkdir, mount it as a separate PV or an independent PV, say LMN, and then again update the etc export. This is a tedious job for the exports guys, right? So I want dynamic allocation of the storage. Now think of it. That is where the storage classes comes into the picture. So what the storage guys will do, instead of doing this repetitively, every time they intend to create an application, they have to call the storage guys, hey, please create a directory for us, right? They have to call them, call or update that we need a storage, because it's a one-to-one mapping between the persistent volumes and the applications and the PVCs. So that is where the storage classes come. Now think of it. Instead of this, if I create a storage class, how? So I don't want this. This is nonsense happening here. And this is a lengthy process. I'm involving the storage guys or bothering the storage guys every time I'm creating an application, and that application is asking for the storage. I'm bothering them. So what I do now, instead of this is the storage. I just create a 1 terabyte storage and mount it on a single folder. Let's suppose I call it K8S data. That's all. That's it. Right. I create a directory and share it in the etc exports. etc exports. And then I expose this directory, the base directory. This becomes my base directory, right? This becomes my base directory, etc exports. So etc exports becomes my base directory, and somehow if I can expose it, this location inside the Kubernetes cluster, right? This is available inside the Kubernetes cluster as a storage class. This is attached to the Kubernetes cluster as a storage class. I call it SC, right? Storage class. So one storage class is created, which is mapped to this particular directory. So what's the benefit? The benefit is that now if my dev test prod team, they wanted to create a application which is asking for the storage. Now when they wanted to create an application, let's say they again wanted to create application XYZ, ABC and all that, right? Now say the prod team, they wanted to create an application here, say ABC application, right? So all they need is they will be creating a PVC for it, right? A PVC. For creating the PVC, I don't need to bother the storage guys. I just create a PVC and tell this PVC to connect to this storage class. Let's suppose the storage class name is blue. Let's say the name of the storage class is blue. It can be anything, or say NFS. Say, okay, let's say it blue, or call it NFS client here. Let's give it a meaningful name. Say the storage class name is NFS client or NFS. Say NFS is the name of the storage. So all I need to tell the PVC. Now for creating the PVC, you need not to bother the storage team. You can do it yourself. All I need to do, I just need to tell the PVC to connect yourself to the NFS storage class. That's all. The moment they connect to the storage class NFS, and when they use the application, the storage class will automatically create, okay, this, I'll just change the location. This entry is in etc exports, right? This entry is in 1 terabyte entry. I can mount it separately on a different block device, and I put up the entry in the etc exports. The moment I create a PVC for the application ABC and tell the PVC to use this storage class, this storage class automatically create a PV inside it. Automatically, PV which is say attached to ABC application, right? Automatically. The thing which the storage guys were doing manually earlier, now the prod wanted to create an application. The prod, they also wanted to create an application, say XYZ. All they need is, they need to create a PVC for it. This PVC will again be attaching itself to the storage class. The moment it attaches itself to the storage class NFS, the storage class will automatically create another PV for the application XYZ. So there is a dynamic allocation of the storage. So you can think of it like the LVMs are getting automatically created, right? We are all coming from a Linux background. So think of it, the moment you create a folder, one LVM got created automatically, and that is the dynamic provisioning of the storage. So every time you create an application, all you need to do is create a PVC. Now test guys also wanted to create an application. They will just create a PVC and tell this PVC to use this storage class. That's it. For this also, the storage class is going to create another PV, say LMN, whatever the name is. That is the idea, and it will automatically create, map it. So you will not be bothering or coordinating with the storage team every time that you want an application and you want a dedicated or a isolated storage. You need not to coordinate with the storage team. The storage class will help you this. So this is all what we are going to learn. So I'm going to create a NFS server. Just create a base folder. I'm just creating a base folder, K8 as data. And inside this, whenever I create a PVC, you will see a PV is automatically getting created inside it, and there will be mapping there. So I will be using NFS for it. So the prerequisite for this lab is that you should have a Kubernetes cluster ready. Sorry, your Kubernetes cluster should be ready, and you should have one more machine which is configured as the NFS server, right? Now NFS server should not be a part of the cluster, but it should be available on the network. So this is what we are going to learn. So I'll clear this thing. So let's see how it's going to work. So I have these Kubernetes cluster with me. If I give you kubectl get nodes, I have these machines ready with me, and these are the IPs. Fine, we don't care about that. Then I have one more machine which is the NFS server here, this one. This is going to be my NFS server. So first thing which I'm going to do here is I need to install the package here. So I do a apt update. So first step, let's configure the NFS server. Give a apt update here. I'm logged in as root, so need not to give sudo every time. So just update it, install the package. So then do a apt install nfs-kernel-server. Install the package. So let's see. So once the package is installed, all I need to create a directory. Though this is not a good way, but I am giving a permission of 777. I created a folder K8 as data and put up this entry in at C exports, right? This is what we are going to do. Say K8 as data. And for all the machines with a very bare minimum permissions, I'm giving read, write, sync, no subtree check. That's all. Save and come out and do a export fs -a, reload, give the command here, show mount -e localhost. Okay, this says this is not, because I might have to start the service, nfs-kernel-server. Start the service and check it out. Systemctl status nfs-kernel-server. This is running, enabled. Now if I try giving the same command, this is working. So consider this, that I had mounted the K8 as data on a 1 terabyte storage, right? So what I'm trying you to imagine, that this K8s data folder, let's suppose I had mounted in the back end on a 1 terabyte block device. So 1 terabyte of the block device is at my disposal. I can use it. So the storage class will help me automatically create multiple PVCs inside it. That's the idea. So this is done. My NFS server is ready. So I can check the connectivity from the manager machine and the workers. So I go to the manager and I can give the command here, show mount -e 10.0.0.99. That is the IP address of my NFS server. The reason it gives me error is because I need to install the NFS client, right? So, apt install NFS common, install the client side package. We are doing this just to check the connectivity, whether that particular share is visible to me or not. So we will do that. Give it a minute, won't take much time. Perfect. Now if I give the same command, perfect, it's showing me. Similarly, I have to do it from the workers. I go to the worker 1 and here again I do a sudo apt install NFS common. This need to be installed, and -y, and I can directly give here show mount -e 10.0.0.99. Let's see it. This should show me the folder K8 as data, which is available on the NFS. So let's check it out. It's good to see the connectivity. Yeah, I am getting it. Perfect. Repeat the same step for the other node. I have a 2-node cluster, so I have to do it for sudo apt install NFS common and do a show mount -e 10.0.0.99. That is the IP address of my NFS server. So connectivity part is good, all is good. And by the way, I have shared all these steps on our GitHub repository. If you are not aware of it, I'll share the URL with you so you can get the code from there. Yeah, perfect. That is done. So I will come back to the manager. I have nothing to do on the workers now. So now if I give a command here, kubectl get PV, I have no PV. Kubectl get PVC, I have no PVC, nothing. And kubectl get pods, I have nothing here. So it's blank. Right, so we have nothing here, nothing. So what the first thing that we need to do, we have the NFS server in place, our cluster is able to talk. I need to install the NFS provisioner. So I have the code available on the GitHub. So if you wish, you can access the code from the GitHub repository. So it will be very easy for you to understand the concept. So this is our GitHub repository, that is github.com/networknuts/Kubernetes. So go here in the storage section, you see this storage class, right? So first I have the steps here, just follow the steps. First configure the NFS server. We have done this part up till here. We have done up till the step number 2. Now I need to add the NFS provisioner. Now the easiest way to do is using the helm as a package manager. So make sure your machine should have the helm installed. I think I have the helm available here. Yeah, for me the helm is available. So if the helm is not available to you, please follow these steps and the helm will be installed. And this is the URL, the official location for the NFS provisioner. So then add the repository, and after adding the repository, give the command helm repo list. So once you give the command helm repo list, I should be able to see my repository. Yeah, NFS subdirectory external provisioner is available. So once this is available, once you have installed it, it is good to create a separate namespace for this. So I'm creating a namespace storage NFS. Please feel free to use any name. I use kubectl create namespace storage NFS, and inside this namespace I'm going to install the provisioner. So just follow the steps, and if you have a different IP address and a different folder, please feel free to change the name and the IP address. So I copy this and paste it here. So this is going to install my provisioner for the storage class. Done. So if I show you here, if I give the command here, kubectl get ns, I have an storage NFS name server there, namespace, sorry, and kubectl get storage class. I have a storage class created. The name of the storage class is NFS client. You need to remember the name of the storage class. That's all. And while creating it, I tell the storage class that this is the IP address and this is the folder which is considered as the root location. So it's going to create a lot of PVs inside the K8s data. What next? This is done. I can describe it. Kubectl describe storage class NFS client. You would see information here. It is not a default one, right? Mount options are not perfect. I get some parameters here. What next? Then I need to create a PV, right? A PVC. So I can either create a single file for all this, but I'm creating this PVC. I have two applications which I'm going to use. So okay, so we have nothing here, no pods, nothing, only the NFS server is available. So what we have to do now, we have to, let me create a folder here, say app1. I'm going to create two applications here. Now you can get the code from the kubernetes.io, or you can get the code from our GitHub repository. That is our GitHub repository, github.com/networknuts/kubernetes. So here in this you will find this storage class. I had already told you this. This is what we are going to do now. Create a PVC. First thing is that the PVC need to be created. So I copy this and say I call it pvc.yaml, or so call it app1 pvc, app1 pvc.yaml, and paste it here. So the only thing which I have to know is the name of the PVC, whatever the name, the permission. As I already told you, you should be comfortable with this. Storage class name should be the name of my storage class, right? So we had already created the storage class and the size is 2 GB. So if I give the command here, kubectl get storage class, this is it. So I created kubectl create -f app1 pvc. So what it does is, the magic of the PVC and the storage class is, it creates a PVC, makes sense, and it automatically creates a PV and it bounds it also. Automatically a PV will be created, and if I go to the storage side, that is my machine here, if I go to the storage, I should see a folder here inside my K8 as data, sorry, K8 as data. I should see a folder here, default, this one, the current timestamp. This is the earlier one which I had used for some other training. This is it. Now what? Now I go back, I need to create an application. So the application code is also here. I'm going to create a service and a deployment which is running on port number 80. So copy this, that's the easiest part. It is always recommended to create a service first before the application. So if I call it, say, what's the name? I call it app or deployment dep.yaml, and I paste things. So this is my service NFS-nginx-svc. The selector is SC-nginx, so that should be the label of the pods. 2 pods I'm going to create running on port number 80, and this is the part here. I'm using the claim name sample-nfs-pvc. This is the claim name which I had just created, the PVC which I have just created. Nginx stores the website contents in the USR share Nginx HTML, so I'm mounting it. Running on port number 80. Take care of the alignments. Yeah, all seems to be good. Save and run it. kubectl create -f dep. It's going to create a service and a deployment. So one service will be created and a deployment will be created. Deployment must have created a replica set. Replica set must have created the pods. Wonderful, guys. So if I describe one pod, kubectl describe pod, any of this, I can see it here. It is mounting the NFS test, right? The claim name. So if I give the command here kubectl get PVC, that is sample NFS, right? This is available here. So this is mounted, that's a volume name. Now if I go inside this pod, I should be able to see it, right? If I go inside the pod, I should be able to see the mount kubectl get pods. And if I go inside kubectl exec -it and any of the pod, and I do a bin bash and I do a df-x, it's a simple Linux mount. See, K8 as data, inside the K8 as data, it has automatically created a subdirectory. Otherwise, if you don't have the storage class, the storage guys had to do it for you. Wonderful. So if I hit onto the service kubectl get service, and if I do a curl onto this curl http / this IP, this is not working. Oh, right. So when I'm doing a curl here, it is giving me error. The error is why it's error? Because I don't have an index.html. So I will go to my storage part, right, and I just created a file here, echo, I say h1, so this is NFS storage class, and I index.html, right? So this is a file there available. This is, and now if I hit onto the service IP, right, kubectl get service, if I hit onto the service IP, this should work, because earlier we don't have an index.html file there. Yeah, this is NFS storage class. My spelling is wrong, but perfect. So the PV is automatically created, right? Kubectl get PV. PVC is all I have to create. So if I run one more application, let's see it. So I create another folder, app2. I go to app2. I have one more code available for you on the GitHub. Here it is. Again, create another PVC. So all I have to do is keep on creating the PVCs. That's all. You need not to create PV. You need not to worry about one-to-one mapping. So I call it, say, PVC app2.yaml. Paste it here. So this I call it Apache NFS. Right. Storage class name should be same. And this application is asking for less amount of memory, no problem. I created kubectl create -f PVC app2. Again, it has created a PVC and it has created a PV also for it. Kubectl get PV. See, a PV is automatically created. This one, Apache, 8 seconds ago. Now let me run application here. So this is my application, same thing. A different application, a different image running on port number 80. Copy, paste it here. I call it app.yaml and run it. The rest of the things are same. Thus, it is using a different image, right? And because it is Apache, so my mount path is going to be var.html. Save and come out and run this kubectl create -f app YAML. It's created a service. So I have got two services now. One is the Apache service, another is this, right? And for this application, when we have checked it, kubectl get PV, one more PV is created. So if I go back to my storage thing and go to K8 as data, see, one more PV is created, Apache one, automatically. So if I go inside this default Apache, I don't have any index.html file. So that means if I hit onto this service, either I should be getting an error or I should be getting the default HTML page. Yeah, I'm getting the default Apache page. Perfect. I can change it. So change can be done from the storage. So if I go here and just create a file here inside this echo, this is Apache app from NFS, right? Anything, and index.html. So we are changing the storage thing. We are changing the application from the storage side. The moment I do this, I hit onto this, I'm getting this. So when I hit onto kubectl get service, see, when I hit onto 76, I'm getting a different application. When I am hitting onto this one, I'm getting a different application. This is NFS storage class. And the best part is that the data is persistent and I hadn't created the PVs. PVs are automatically created. Now think of it. If you have a 1 terabyte storage mapped to K8s, right? Suppose this is the folder which is being mapped to K8s data, right, on the NFS server. This is mapped to a 1 terabyte storage. So the moment you create a PVC, because of the storage classes kubectl get PV, one PV will automatically is getting created for every application. So inside this, it is automatically creating different folders or the PVs for different application. One folder for one application, another folder for another, like this. It keep on creating it. And all you have to do, like the storage guys has to do, just take care of the space. If the space, they are saying, oh, we are getting short on the space, it can be on the LVM, they can increase the size. We know the concept of LVM, so this keeps on adding, right? This is the idea behind the storage classes. Dynamic allocation of the storage and dynamic provisioning of the persistent volumes. All you have is a storage with a space available. I hope you have understood it. The storage thing, try doing it. Do comment on how you like it. Subscribe if you like it. Share if you like it. Thank you very much. I'll see you soon. Take care.